Welcome back, Honors Algebra 2. We are on Chapter 6, Day 7. We're going to talk about logarithms with other bases. So the big takeaway from today is you need to realize a logarithm, in other words a log, is the same thing as an exponent. It's just in a different form. Right down here we have y equals log base b of x is equivalent. Notice those arrows in between. It's the same thing as b raised to the y equals x. Now, it seems a little confusing, but we'll go through all these notes today and we will be pros at changing from logarithm form to exponential format. Okay, we're going to go back and forth using these letters, using this formula. Okay, a couple facts. Y is the logarithm. So see how it equals this log? So y is the logarithm. In the exponential, notice it's the exponent. It's raised to the y power. B is the base. Notice it's the base for the log as well as the base for your exponent. Some things about the base. It needs to be positive. Needs to be positive or greater than 0. And it also cannot equal 1. We'll do a lot of examples and I'll explain it further, but there is no log base 1. X is the argument. Notice the argument is what comes after the log base, and it's also what the exponential form equals. A couple things about the argument. This also needs to be greater than 1. Needs to be greater than 0. And this one cannot equal 0. So a couple facts about the variables from your logarithm to your exponential. So first part is write the following equations in exponent or logarithmic format. So let's see, looking here, log base 2 of 16 equals 4. That's in log format. We need to get it in exponent format. So I'm going to look at my variables. Notice b in this case is 2. When I put it into exponent format, 2 is my base. 16 is the argument, that x. In the exponent form, it's what your equation equals. Y is 4. Y is that logarithm that turns into the exponent. So you just rewrote that log format into exponent format. Now, it should make sense, right? 2 raised to the 4th power is 16. So look at that. It actually works. Base raised to your exponent, your log, will equal your argument. Now let's go the other way. You have 5 cubed equals 125. So I'm going to have log, my base is 5, so put a little subscript 5. The argument is x, so that's 125. And it's going to equal my exponent, which is the log. And you can check. 5 to the 3rd power is 125. And this is the proper format in log. You're going to want to be familiar with getting in from each form. Please use this conversion up here. They're equivalent. Now we're going to do the same thing but actually solve for the unknown. In the first problem, it wants us to solve for the argument. The argument, if you go back to the top, the argument is the x value. And notice that's the only variable I have. I'm starting out in log format. I can't do much in log format, so my first step is I'm going to go on to exponent format. So that means I'm going to take my base, raise it to -3, and that's going to equal my argument. Same conversion as above. Now we have exponents. We work with exponents. You can't have negative powers, so you bring it to the bottom, make it positive, and then simplify. You just solved for x by first taking your log format and putting it into exponent format. Same thing with the next one. You're going to take your base, raise it to 7/5, kind of weird, yes, but you're going to do it, equals your argument. Now, we're just filling out our exponent rule. We want to simplify this. Now, without a calculator, we can't just type this in and hope for the best. What we're going to do is try to rewrite 32, and notice how I write this, to be raised to a power of 5. Now, the reason I chose 5 is because when you do a power to a power, you multiply. So the 5 and the 5 in that denominator of the power will cancel. So I'm trying to make my life easier. Is there a way to write 32 in terms of something to the 5th power? Well, yeah, that's 2. So I did that because I want to cancel out my powers. The 5 and 5 will cancel. I'd be left with 2 to the 7th. I'm left with then 128 equals x. We'll practice that a lot, but your goal is to get your exponent to match the denominator of the other so that it can cancel when you multiply. One more in this section. You're going to take your base, raise it to your exponent, equals the argument. Options here, because you have that negative exponent, you can move it to start. We can simplify and then move it. It's your call. In the end, we will be moving that negative exponent to the bottom, but why don't we just start with simplifying? So my goal, just like I did in the last problem, is to rewrite 216, my base, to have a power of 3. The reason I chose 3 is because 3 is the denominator of the power it's being raised to. Power to a power you multiply. So that's my goal. Okay, can I write 216 in terms of a base raised to 3? Yeah, I can do 6. Now it simplifies to just 6 raised to the -2 power because those 3's cancel. I'm going to go ahead and move this now to the bottom and make it +2 because that negative exponent. So I get x to be 1/36 equals x. The next part wants us to solve for the log. In our equation at the beginning, the log is the y variable. In this case, do you see how they just call it x? So you can call it any letter you want. Above, we just labeled it as y, but as long as it's what equals that logarithm, that's the same thing. So, again, we're in log form and we're stuck. First thing you want to do is put it into exponent format. So you take your base, raised to x, equals your argument. Well, we did learn a rule in our notes previous to this, that if you have like bases, your exponents will be equal. Let me write that down. If you have like bases that are equal, actually I'll do, if you have equal like bases, again this is in your other notes, so if you have equal like bases, that implies you have equal exponents. Okay, that shouldn't be new. So what I'm going to try to do is rewrite 234 to have a base of 3. Oops. The reason why I want base of 3 is because the left side has a base of 3. 3 to the what power will give you 243? Well, that would be 5. Now I have equal bases, so my exponents are equal. Look at how nice that turned into. Next one, 3 to the x is going to equal the argument of 127. My goal is to get a base of 3 on the right side. I have 3 to the x over here. Do you notice that this is really 1 over 3 cubed? Rewriting, this is really 3 to the negative cubed. And I know you're like, oh no, negative exponents, you can't have it. But now we have equal bases. That's what we need. 3 and 3. I can do a little rearranging, enough to show that x will equal negative 3. And you can even check. For both of these, you can go back and check. 3 to the 5th does give you 243. 3 to the negative 3rd does give you 1 over 27. You try the last one. Okay, hopefully you paused the video. You're going to take your 49, raise it to your x power, is going to equal 343. Now, if you got the right side to have a base of 49, okay, but do you realize the left side can even be simplified further? I can rewrite it as 7 squared. Can I get 343 to have a base of 7? Yeah, 7 cubed. So I have 7, 2 times x, power to a power. Equal bases means equal exponents. X would equal 3/2. Okay, so you always want to get your base as simple and small as possible, and then you can have your exponents be equal. Just a couple more examples, making sure you feel confident. We're going to do the same thing now on the back side. We're going to have your base raised to x equals the argument. We're going to do the same thing as the last example and really simplify both terms to the smallest base. Hopefully you realize 2 squared is the smallest base of 4. And I'm really hoping I can get 32 to have a base of 2. Well, I can. 32 can be written as 2 to the 5th raised to x. Power to a power, multiply those exponents. You have your like bases. Set your exponents equal. X would equal 2/5. 81 raised to the x would equal 1 over 27. Please pause, try it on your own. Hopefully you paused and we realized 81 and 27 share a common base of 3. So you'll have 3 raised to the 4th power is equal to 81. And 3 raised to the negative 3rd power is 1 over 27. Notice because it's 1 over 27, it was in the denominator. Move it up to the numerator so that you have those common bases. You have 3 raised to the 4x equals 3 raised to the negative 3rd. Equal bases, equal exponents. Okay. Hopefully you did good on that. If you made any mistakes, please correct. The last section is now solving for the base. So we have solved for the argument, then the log, now the base. Similar formats is just simplifying it into exponent format. So you're going to take x squared equals the argument. Make sure you transfer log into exponent as your first step. It will help every single problem. Now we just have to get x by itself. Well, you could just take the square root of both sides. And you will get x equals plus or minus 4. But wait, exponents, they can't be, the bases cannot be negative. Since the bases can't be negative, the only option is 4. Okay, so write down here, this base, whenever you have any bases, they cannot be negative. Let's try the next one. You will have x raised to 1/4 equals 2. Just change into exponent. And now we need to undo that power of 1/4. Well, think about our power to a power rule. If we raise both sides to 4, the left side exponents can cancel out. 1/4 times 4, 4 over 4 is 1. So you have x to the first equals 2 to the 4th, 16. You have next example, x to the 4/3 equals your argument. I want to undo that exponent. I want to get it to be 1. So think about it. What should I raise both sides to in order to get x to the first? Well, I need to put a 3 in the numerator, 4 in the denominator. So when I multiply, I'll get x to the 4/3 times 3/4 equals my right side. Here I'm just showing it out. Cancel, 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 cancel. I'm left with what I want. And now I kind of do the same thing on the right. I need to simplify. No calculators, you can't do that. So I'm going to try my best to rewrite 81 with a power of 4. This is just like from the beginning. I want to get 81 to be rewritten with a power of 4 so that the denominator of my exponent and the exponent will cancel. You can rewrite 81 as 3 to the 4th. Nice. This looks good. That means I'll just have x equals 3 cubed because those 4's will cancel. X equals 27. Last one, fractions, my dears. We can do it. First thing, you're in log, you're stuck. Go to exponential. X to the 3/4 is going to equal 125 over 27. Log to exponent. Now you're pros. Think about what we need to do. We need to get x by itself. Just like the last problem, it's actually very similar. We have to multiply by, raise. I don't know why I say multiply. You have to raise both sides to the 4/3 power to cancel out the exponents. This left side just becomes x, same reason as before. If you want to write it out, go for it. And now I have 125 over 27 raised to the 4/3. Look back at the last example. I rewrote 81 to have a power of 4 to cancel the denominator. Well, is there a way I could possibly rewrite 25 to have a power of 3 and 27 to have a power of 3 in order to cancel with that denominator? Well, yeah, you can. 5 cubed is 125. 3 cubed is 27. This is looking nice because these will cancel. I'll have 5 to the 4th over 3 to the 4th. That would be 625 over 81. A lot of algebra, a lot of steps in here, but it builds from our exponent rules. So make sure you look at your exponent rules. Make sure you look at your power sheet so you can realize 81 is equivalent to 3 to the 4th. All of that can be using our resources for the beginning, and then we will keep going. Good luck. Bring questions to class.